In this video, we're going to go over some applications of linear systems. So, as our first example, consider a total of $12,000 is invested in two different funds paying 5% and 3% simple interest. Okay? So this is like an investment question. The total annual interest is $500. Okay? So then the question is, how much is invested at each rate? So to set this problem up, first we know that we have two different amounts of money. Let's call it X and Y. Okay? So these are both amounts of money, and this is going to be the amount invested at this will be the amount invested at 5%, and this will be the amount invested at, amount invested at 3%. Well then, if those are the two amounts, that means that in total, we know we have 12,000 that was invested, so X plus Y should equal 12,000. Okay? But then, we also know that the total amount of interest was $500. How do we calculate interest? Well, we take 5% as a decimal. So here, let's go further down here, and let's say the interest will then be what? Well, it would be 0.05 times X, because you take 5% of whatever your amount was invested there. For instance, if you invested $100, you expect to get $5 in interest by the end, because that's 5% of 100. Similarly, the interest for this account will be in total 0.03 times Y, because it's invested at 3%. So, in total, we know the total interest is 500, so that means 0.05, let me line these up actually. 0.05x plus 0.03y is going to equal 500. And so we now have a system of linear equations. We can solve this now. Let's go ahead and use substitution. We're going to go ahead and solve out for x in terms of y first so that we can substitute in. So that would be 12,000 subtracting y to the other side. We get x equals 12,000 minus y. Substituting that back in, we'd have 0.05 times 12,000 minus y plus 0.03y equals 500. Now, 0.05 times 12,000 of y, you may say, well, I don't know what that is. Well, you know, this is 5, this is 0.05, and so this is, if it was 0.5, it would be half, which would be 6,000, and then it would be a tenth of that. So it's going to be 600. It's going to be 600. .05y plus 0.03y. So I distributed the 0.05 through both. Equals 500. Putting those together, you're going to get a negative 0.02y. So you get 600 minus 0.02y equals 500. Subtract 100 to the other side, and you will end up with 600 to the other side, and you'll get negative 100, so negative 0.02y equals negative 100. And then if you go ahead and you divide both sides by negative 0.02, you'll end up with y equaling 5,000. So that's how many dollars. So 5,000 was invested in this account, in this first account, the amount with 3% interest. For the other account, well, we can go back and substitute into here. That would be 12,000 minus y, which is 5,000. So that's going to be x would equal $7,000. At this point, you should make sure that when you substitute both these values into this equation, that they work here and actually give you the correct amount of interest as well. And now it's time for you to try an example. So let's try another one where it's 25,000 is invested in two funds paying 6.5% and 8.5% simple interest, respectively. And then the total annual interest is going to be 2,000 this time. And then the question is how much is invested at each rate. On the count of 3, per the usual, I will reveal the answer. 1, 2, 3. So you see here that we're going to go ahead and let x be the amount invested at 6.5%, y invested at 8.5%. So we end up with this set of equations similar to last time. Now I'm going to use a little trick here. Sorry, I should have done this in the last example as well. But I'm going to go ahead and multiply this equation by 1,000 on both sides, which actually gives 2 million there. So you end up with 2 million on this side. You then get 65x and 85y. It's just easier to work with those numbers instead of all the decimals. You go through and you'll end up with, once you've done the substitution and everything, you'll end up with y is equal to 18,750, which means substituting that back into the equation for x will be 6,250 for x. As a second example to work, consider that a shoe company invests $300,000 in equipment to produce a new line of athletic footwear. Each pair of shoes costs $15 to produce and sells for $70. How many pairs of shoes must the company sell to break even? Now first, we need to describe what we mean by break even. Breaking even means that this is the point where your revenue, which is the money you take in from selling, so from selling equals cost, which is from producing, right? So whenever you make a product and want to sell it, there's a certain cost to produce it. And then revenue is how much you get from selling it. Breaking even is when you get a profit of 0. So in other words, you may say, well, I want to get a positive profit. Well, yes, but you have to break even before you can actually get a profit of 0. So breaking even is essentially what happens. It's sort of the point where it's like you never even started selling things. It's where you can actually start making a profit because you've overcome your costs. So that's all we're asking here. So they invest $300,000 in equipment to produce this line of shoes, okay? Now, so let's look at our costs. Our costs are, well, we have the $300,000 that we have to actually put in to start up this company. But then each pair of shoes costs $15 to produce. So we have costs is equal to 15x plus 300,000. On the other hand, we also have revenue is 70x. Because we get 70, give me a moment. So this is when we get exactly, so it costs $70 for someone to purchase this pair of shoes. That's how much we're selling it for. And so that's how much we make. We make 70 times each pair of shoes that we get, right? So Together, what we actually get is we can get a system of equations by recognizing that we know the cost needs to be 15x plus 300,000. And breaking even would be when the cost, key point there, is the same as the revenue, which is 70x. So this equation is really saying C equals R, which is what it means to break even. So we have this system of equations. We can go through and solve for x. So here we actually see C is equal to 70x, so we can put that up there. We end up, and that would give us what? That would give us 70x equals 15x plus 300,000, which isn't that surprising given that this is exactly revenue equals cost. Subtract and you end up with 55x equals 300,000. Solving that out, you will get x is approximately 5,455 pairs that we have to actually sell to break even. So now it's time for you to try an example. Go ahead and rework the same example that I just did, but this time where shoes instead cost $12 to produce, and try to figure out when do we break even? How many do we have to sell? On the count of 3, I will reveal the solution. 1, 2, 3. So this time, instead, we have C equals 12x plus 300,000 instead of the 15x, but the revenue is still 70 times x. So we'll end up with C equals 12x plus 300,000, and since we want to find the break-even point, C equals 70x still. That is 70x equals 12x plus 300,000. Simplifying, we end up with 58x equals 300,000. Divide both sides by 58. You get x is approximately 5,172 pairs of shoes that we must sell to break even. For more practice and working some of these types of applications, see the textbook, section 7.1, pages 475, 476. Work those exercises out. And in our next video, we'll start discussing the method of elimination.